So now I will discuss about the economic feasibility, and we will perform the environmental analysis that is related to hydroelectric power. The hydroelectric power stations have contributed to meet our energy demand for more than 100 years. The cost related to this and the evaluation of the relevant environmental impacts will be discussed in the following upcoming discussion. So, we have performed the uh, environmental and economic analysis of the solar power and the wind power plants. Similarly, we will define the selected plants that will be subjected for the we will be defining the reference systems for the hydroelectric power generation that will be subjected for the economic analysis. It has to be considered that the run of river power stations as opposed, for example, to wind energy conversion systems or the photovoltaic plants are power stations that are largely determined by the prevailing local conditions. Thus, the material input and with it the costs involved can sometimes vary significantly for the different run of river power stations. So, it is a generally applicable cost that estimates and can therefore only be made to very limited extent. So, the considering the economic analysis, the hydroelectric power stations are characterized by a number of possible design types. Therefore, uh, we have selected only one type for a reference plant that can be analyzed here and ought to be seen as example for possible plant configurations defined by the specific local conditions. This is particularly true for the structural components like water intake and petstock power and powerhouses, which sometimes vary a lot in different hydroelectric power stations. So, within our analysis, we will take a closer look at four hydroelectric power stations as their reference technology is typical for extensive uh, uh, extensively that is extensively being used throughout the world. So, considering in this table, according to this table, it is distinguished that between the two small hydroelectric power plants with an installed electrical power of uh, 0.032 megawatt or uh, zero point 0.3 in megawatt. Uh, respectively, and the two larger plants with a power of 2.2 in megawatts and 28.8 in megawatts respectively. So let's consider the first one, that is 32 kilowatt low pressure power plant, that is the power plant 1. The water is delivered at a small dam and it will then be processed with a head of 8.2 meters via a 110-meter long fiberglass pipe with a Kaplan turbine. The electrical energy generated by the directly coupled synchronous induction generator is fed into a low voltage grid that is now the second one is the plant 2, that is the 300 kilowatt low pressure plant. The power stations utilizes the head of 4.6 meter created by the concrete dam followed by bypass reach of 200 meter from the intake structure. The headwater channel will lead directly to the power station. The electrical energy generated by the Kaplan turbine connected by the transmission to the synchronous generator is fed into a medium voltage grid near the power station via transformer. The next is the plant number 3, that is 2200 uh, uh, kilowatt or 2.2 in a megawatt. It is a low pressure design, and this run of river power station is designed as a river power station. The head of around 6 meter, and uh, is created with the dam. The backwater reach of almost 200 meter is secured by longitudinal dikes. The hydraulic energy is then converted into mechanical energy by Kaplan turbine, and then further converted into electrical energy by the synchronous generator. So this electrical energy is will be fed to the medium voltage grid next to the power station via transformer. The last one, or the system 4, is the 28.8 megawatts or 28,800 kilowatt low pressure plant. This run of river power station is also designed as a river power station. The powerhouse is located in a riverbed with a catchment reach of approximately 8.8 kilometer. It achieves a head of 8.3 meter. The two Kaplan bulb turbines have a combined capacity of 425 cubic meters per second, and the electricity from the synchronous generators is fed into a high voltage grid via two transformer and mm, uh, a metal clad that is made up of sulfur hydrofluoride switchboard plant. The hours at peak load, which is basically calculated on theoretical values of the analyzed plant, are in line with the dimensions typical for such plants installed in Europe. The technical lifetime of the structural components is assumed to be 70 years, and the machinery plant components to be 40 years. For the plants use for the plant owned, it use only 1% of the produced electrical energy, uh, and it is basically considered in the assumptions. So, in order to be able to estimate the cost that is associated for the hydroelectric power stations, the investment cost and the operation costs will be analyzed. Uh, the specific electricity generation cost are uh, or will be derived from these costs that are associated with the hydroelectric power systems.